Thanks for coming. I hope everybody's still roughly awake. Roughly. This is the last session before everybody's dismissed and can enjoy the day or / go to the Data Fest and hear a lot of more cool talks. This is the session on data maturity, the data maturity framework and your organization, and it's really a response to a lot of the first or 1.5 conversations we'd have with project partners being very similar to each other and leading to the same set of questions we ask. And so a bunch of people from our lab and a bunch of people from DataKai sat together and said, like, why don't we write these down? We will, if this works, not yet, we will briefly go through the why and what of data science and some of the challenges that data science projects normally exhibit. And then we'll jump straight into the data maturity framework, and I'll walk you through some parts of it, but then I'll leave it to you guys and we'll have groups work through it together. Can I get a quick show of hands? Who considers themselves primarily a technologist? Who's primarily a technologist? And who's primarily somebody who works on the project side of a social good organization? Who's more on the project side? Okay, cool. That's actually pretty balanced, which is great. We have a few more technologists, but that's fine. All right. So data science uses historic information to identify patterns or predict future events. A very vanilla definition of the issue. So at the core of data science, there's really just a bunch of algorithms that are good at generalizing from historic examples to future problems. So you could say, isn't data science just statistics? Like, statistics, after all, is the science of making inference from data, and that seems to be what data science is doing as well. And I'd say that's only partially true. They're a little bit different and kind of the same, and that's because data-driven decision-making has changed quite a lot in organizations and companies in recent years. For one, a lot of companies nowadays do their business online via mobile apps or websites, and that naturally lends itself very well to collecting a lot of information on your customers. But other organizations nowadays as well routinely and automatically collect a lot of individualized information on their clients or customers. And then the other aspect is there's been a bunch of technological advances in the last 2 decades roughly. And finally, a lot of business practices have changed as well. I think nowadays there's just a lot more companies and organizations willing to use their data to influence their operations. So nowadays, a lot of organizations don't just do long-term strategic decisions based on statistics, but they really use data to influence what they're doing on the ground with their customers or clients. Right. So what it means to put statistical inference into operations, into what you're doing with your customers or clients on the ground, I think there's 4 aspects roughly. One is it's oftentimes based on extremely granular data. Like you collect data about individual people, individual actions, no longer about broad populations. Another part is because of that, it needs to be somewhat automated. You can't just go and do an analysis like you would have done 10 years ago, 15 years ago on each and every one of your clients and customers. That's time prohibitive. Thus, it needs to be automated. Data science projects oftentimes are predictive. Traditional statistics oftentimes are retrospective, where you look back and you're trying to figure out what happened. Instead, nowadays, you'd oftentimes try to make a prediction about an individual's behavior and say, like, this person is probably wanting this, or probably doing this soon. Thus, we should change what we're doing. And the organization or company changes its actions. So the 4th point is these highly granular actions, right? You start with very granular data about individual people, and you end up with decisions and actions that are targeted at one person most of the time. Most vanilla example I could possibly come up with for any data science project is like how Amazon reaches out to customers, right? So in the old days, Sears wants to sell a bicycle, right? And maybe market research tells them, you should sell more bicycles to the suburban population. So they would come up with some TV ad that advertises a bicycle, and then they put that on a TV show that's popular with suburban people. Okay. Nowadays, obviously, Amazon has a lot more information about you. They know what you've bought, if you've liked it, if you've returned it, how you paid for it. They know what you've looked at, what you've clicked on, how much time you've spent on it. And they know the same thing for all the articles about the other people who bought and looked at them. So when you've bought something, or if you want to buy something, Amazon looks at all the information they have on you, and then they might look across all the articles they have in their assortment and try to figure out, if I advertise article X to this person, will it increase their customer lifetime value for me as a company? And then they send an email saying like, why don't you buy this? And maybe you'll say, great, that's exactly what I was looking for. That's always creepy. So they have very granular data on you, and based on that, they take very granular actions. Another example is the Obama 2012 campaign, where a guy used to work at, instead of just mass mailing everybody to go and vote for Obama, they would build two models. The first model being, is this person likely to vote for Obama already? And if you're likely to vote for Obama already, there's no need to send you anything, because that's a waste of money. The second model they built scores you on your probability of being swayable. Because if you're a die-hard Republican, there's no need to send you anything. That's a waste of money. So they would only target people which had a high probability of being not voting for the right candidate yet, and of being convincible once you spend money on them. So again, very granular interventions. This is an example, third example, again, kind of commercial, from a company I used to work at, Zalando. They're a e-commerce fashion retailer in Europe, sending out millions and millions of articles each year and running huge warehouse operations throughout Europe. Now, Zalando allows its customers to order stuff and then return it for free, right? So you get the box, you open it, you look at the pairs of shoes you don't like them, you toss them back in the box, you tape it closed, slap a return label on it, and give it to the postman. And they don't charge you for that. And obviously, a lot of people make use of that, right? They order something, try it on, don't like it, return it, which costs the company a lot of money. So they would ask the data science team where I used to work to build a predictive model that tells them which article is probably coming back. So we would look at, again, all the information we have on you. What have you bought? What have you liked? What have you returned? When did you buy something? How did you pay for that? If you bought a mini skirt at 3 a.m. or if you bought a bar of soap at 9 a.m., very different return probability. Very different return probability. We would look at the articles. Is that article likely to come back? And so on, and so on. And then we would make a prediction on whether you would send back this article. And there's loads of stuff you can put into that model, like these boxes, right? They contain several articles. Did you already return a different article from that shipment? Most likely you've used that box. So most likely you won't return anything else, because you don't want to go out and buy another box, put your thing in it, return it. Okay. In Forbes' buzzwordy way of saying things, predictive analytics is emerging as a game changer. Instead of looking backward to analyze what happened, predictive analytics help executives answer what's next and what should we do about it. Much nicer said by a project partner of ours who just said, we are used to using data to justify funding decisions. Now we can use data to improve what we do. From retrospective statistics to predictive operationalized statistics. Great. Now, the examples I gave you were, like, for one, slightly marketing heavy and very commercial. And I think most of us are not exactly interested in that type of project, speaking for myself here. The type of data science intersect social good problems, like that space, I think is mostly dividable into 4 broad categories. One is, well, actually the last one I started with, data-driven policy recommendation and evaluation. That is your traditional, I want to change some law, I want to change some rule, what's the likely effect on, say, the economy? That's like the very researchy public policy / economics part. But then the first 3, those are more operational. So let's say early warning and intervention, right? So that could be, for example, which police officer might have an adverse interaction with the public, and then based on that prediction, which interventions should we offer? That's a early warning system. Or resource allocation. So for example, you need to inspect homes in Chicago for lead-based paint, which poisons babies, right? Like, you have this old paint in houses, babies eat the paint, they get lead poisoning, it's very bad. Thus, you need to inspect the homes. But inspections are expensive, and we don't have enough inspectors. Which houses should we inspect first? So you could make a prediction saying, which house is most likely at producing a poisoned baby in the next year? And maybe that's the house we should check first. So efficient resource allocation. Effective advocacy and fundraising, that's very similar to like the Obama 2012 campaign, right? You have a constituency, or you have people you want to reach out to and engage them with what you're doing, and maybe get them to give you money or votes or whatever. How do you do that most effectively? So that's a bit marketing. Yeah, quick show of hands. in your organization where you currently work, do you see potential for an early warning project? Okay, and efficient resource allocation, could you come up with a project in your organization? More. Effective advocacy. Yes. And data-driven policy recommendations. Cool. Right. So data science kind of is operationalized statistics. But obviously, to do any kind of tech requires a bunch of tech resources around that. It's tricky. And data science is no exception there. That led Drew Conway to come up with this really nice Venn diagram, which says, like, if you want to do data science, you need to be a subject matter expert who's awesome at math and stats and can hack. Okay, so you're a unicorn, right? Those people are extremely rare. Like, that's a phrase, like good data scientists are as rare as unicorns. The response to that, of course, cannot be that we all move to fairy tale land. Right? The response to that must be we need to have teams that complement with complementary skills. And that comes with a bunch of challenges, like leading teams that come with complementary skills is tricky. So data science projects are hard team efforts. They're cross-sector coalitions. So if you want to lead a data science project, you need to be able to clearly connect with organizations. You need to be able to lead and build cross-sector team. And we've seen that in the examples, why that is important. So you need people from the intervention side, from the data collection side, you need your analysts, your data scientists, and your leadership all around effectively talking to each other. You need to be able to sell and see the big vision because it's a tech project and it will run into problems that you didn't foresee. So you might run over budget, you might run over cost. If you run out of runway due to that, that's the problem. So you need to be able to keep the big picture and you need to be able to sell that and get support from your funders or from your leadership. Same reason that fuels these, patience, persistence, perseverance, the P values. For the same reason it's tricky. Managing risk and opportunities, right? Presumably, this is new technology. It could pay off very well. It could improve operations and really have impact. But of course, it's a tech project. Thus, it can be tricky. Thus, it might fail. Thus, you might burn a lot of money and time. And that's bad. And you need to be able to manage and shoulder that risk. And finally, the openness benefits. Oh, we already talked about that, how it's very interconnected projects. Yet another complication. Data science is a buzzword and cool and hyped at the moment. And technology that's being hyped goes through these phases, kind of. It starts out, somebody invents something, then everybody hears about it and thinks it's flying cars and artificial intelligence and the robots are coming. And then at some point people realize that none of that is true and it's much more mundane. And you have this disillusionment through. And then at some point it's settles where it's actually productive and where it's realistic. And we are, at least in data science for like social good applications, definitely not here. And I'll leave it up to you where about we are in this. You can look into that. All right. So if you manage a data science project, you need to manage expectations, both internally and externally. Your funders might get overexcited, and your employees might get overexcited. Super daunting. Loads of eyes and loads of things that can go wrong. And it's all a bit overwhelming, I think. There's so many things that you need to pay attention to. And so I'd say, let's roll this back, let's take a step back, and let's try to focus on a simpler question, and that is, what's the biggest challenge? Can we identify the one thing we should fix first, and then take it from there? Normally, when we start scoping projects, the questions we ask fall into one of these two categories, like technical stuff and organizational stuff. Do you have the tech resources in place? Do you have the people in place? And it turns out that the 1.5th conversation we have with organizations, after the, hey, this is cool, maybe we can do something together, you work on interesting problems, we work on technology, let's do stuff. Right after that comes the, okay, let's talk about, so what data do you have? Like, who are the people working in your organization? What do you care about? And so on. And these questions tend to be very similar from conversation to conversation. And that's why our lab and DataKind sat together and made this questionnaire to kind of like put those onto one sheet of paper. And yes, big shout out to Aaron Eckert from DataKind, Laura and Matt, and Joe and Ray from our center for doing that. It's none of my work, I just get to share it. The data framework has like a bunch of different subsections, and we don't have to go through all of them right now, but I will touch on a few, and then we will go into workshop style, and everybody's going to walk into use. One big subsection is data readiness, and we can break it down further into data capture. That's kind of the first question. It's like, do you capture data about the people you care at all? Or do you just not collect data on them, which is possible? And that's going to be very hard to do a data project. And a high maturity on this dimension would be if you automatically, programmatically capture data on the people you're trying to serve. Relevancy and sufficiency. This is Jane's favorite slide ever. How to make apple pie, not with oranges, right? So you might have data that is not that is irrelevant and insufficient. So let's say you want to predict which children are at risk of lead poisoning from lead-based paints in their home, but you have no historical data on which children have been poisoned, right? Then it's going to be impossible to learn the relationship between lead poisoning and any other attributes. And then medium maturity would be something like some of the data you're collecting is relevant, but it's insufficient because it's defective. So for example, you might be collecting data on school dropouts, and you want to make a prediction midterm who's at high risk of dropping out, but the unique identifiers are missing. Like your student ID is missing from the data due to privacy or something. Right? So you have data that's kind of relevant, but you can't really link it to anything else, so it's insufficient for it. Storage and format of your data, super important if you want to work with it. Low maturity would be your stuff is on paper, right? Like some organizations have their data on paper or PDFs, and that's just very costly to work with. Like that's a lot of effort. And then high maturity would be okay. It's maybe in some proprietary format where you first need to buy some expensive software to get into it. And then high maturity would be, it's like some standard open form like CSV, JSON or something, and it can be fetched through an API by any program, super convenient. Here, this is a project from this, an example from this lead project that I mentioned, where we made predictions about which houses are likely to produce lead poisoned children in Chicago. And for the question like how's the data stored, right? Like it falls on two parts: advanced, like okay, there's some on Amazon, some CSVs lying around, and then everything else is in a database that can be plugged into. So that's awesome. Data quality, another big issue. Have your rows errors, or are they missing? Or is the data machine readable? That's another big thing. Right? If you have these Excel spreadsheets, a huge spreadsheet, and then there's a box somewhere in it, and it's like it says like highlight. It's just like okay, this is like explaining the data, or like you have like, and that's not machine readable, right? Like you have not just rows and columns, but it's like weird box all of a sudden that's like just in there. And you need to manually remove it. It's not good. I'm telling you, it's not good. Then medium maturity would be something where your data might have errors, but they can be programmatically wrangled out. Like maybe your date format changed at some point. Like half your dates of birth are like recorded that way, and then half of them are recorded this way, and so you need to deal with that, but it's not a big deal. And high maturity would be like error-free, consistent, and complete. So in the lab project, it's looking pretty good, except the blood test names and the dates of birth are typos. So you need to clean those. Another one that's really important is integration. You might have different tables, different data sources. Can you link them to each other? And if you cannot, then they're not very useful. So low maturity would be something like your data is stored on some specialized system and it's never taken out. It just sits there. It's there. Medium maturity could be something like you have, say, like you're a school district, right? And you have the data in PowerSchool, and then you do an export occasionally, and you have this big CSV. And then you have a second table with information on your students, and you link them kind of like ad hoc, like maybe based on name, because there's no unique identifier, right? But obviously name is not unique, and they could be spelled differently, so the matching is kind of not super clear. So you take this ad hoc export, and you match it like in an ad hoc way with this different table, and your results are kind of screwed up because the names aren't unique. That's like not great, but better than no linking at all. High maturity would be something like it's stored in a database and there's unique keys across all tables, so you can like automatically, perfectly link it. It's nice and clean. Oh, and then very high maturity, and we've already had one person whose organization is doing that. You're also putting in external data and integrating that into your internal database. Is anybody doing that? Like automatically for your internal clients? Like plugging into some other data source, grabbing the data and making it part of your internal data? Awesome.
But there's a big ETL process involved in order to do that. Like this is a separate team.
Right. So that's very much. Cool. So this is from the lab project, and by the way, that's a project that's happening, right? And it has impact and it's being implemented and all that stuff. So just to show that not everything needs to be on the super awesome side of all dimensions. So in the lab project, the data was sitting in separate source systems, and it was really tricky to match it, to link the records. And it didn't kill the project, but it definitely caused a lot of cost and a lot of effort to do it. So it had to be, people had to be matched by names, right? But that was far from perfect. Like the names were misspelled, people have identical names. So not we had to work on this, but Eric and Jane had to use like quite involved approaches to have like a supervised way of saying which records are likely to be identical, and then the system was learning from that and automating it from that. So big effort. Accessibility, yes, another dimension. You can imagine, if you're in your organization, if nobody accesses your data or like very few people can use it, that's low maturity. And high maturity would be if you make it accessible through an API to everybody, like you share your data openly. Almost self-explanatory. Also, like let the project, right? It falls onto several things at the same time. So the blood test inspection data sits in specialized places, but then the county assessor data is in a database that can be plugged in, and then the city building data is actually publicly available through an API. So different rates on the same dimension for one project. Anybody who's ever been part of the fellowship, the Data Science Associate Fellowship, knows that this is super important, like documentation for your data. Like, do you have a data dictionary, for example? And low maturity would be, nobody knows what your columns mean, and nobody knows what your codes in your data mean. And then just one step above that is the guide, where like somebody in the organization knows, who's probably been there for like 3 decades, and if anybody wants to know what this one code in this one column means, they pick up the phone and they go like, can you help me with that? Or she or he, and they just ask that person, and they have it in their head, and that's the only place it's at. And if that person ever leaves, the whole analytics team is gonna go down. Like that is like still really low maturity, but quite common. It's much better if you have some place where that's written down. You have some data dictionary that spells out all the column names and spells out all the codes that are what they mean. Even better if you have some kind of metadata, right? If you have some kind of explanation of how and where and by whom and when that data was connected. And even better if you also know which data wasn't connected but should have been and why. Or if you know what biases your data might have due to how it was connected. So if you thought and documented your thoughts about how your data might not be representative of the things you would like it to be representative of, that's awesome. For the lab project, data dictionary, like simple data dictionaries that exist that like at least spell out most of the variables. All right. So if you think back to the first bit, we talked a bunch about how data science projects are like across sectors, right? And you might have noticed that all these parts, these dimensions we talked about in data readiness, they're really even more important when you want to have new people plug into the same tech. Like documentation, accessibility, quality, formatting. These are all super important if you have a mixed team that approaches a new problem. So important, in fact, that I put a silly picture on. Silly pun because cross-sector, it's a Kiwi. It's funny. Anyway, at least like, now you want to just to burn it into your brain. These are important, okay, for cross-sector. The other dimension is obviously organizational readiness, not just tech readiness, and for example, like leadership buy-in, right? Like your leadership has loads of requirements, and you don't need to go through all of them. They need to be able and willing to manage data and tech risk, right? Super important. It might not work out. It might take longer than expected. You might run into obstacles you didn't know about. If you can't manage and remedy those risks, you're gonna have a really hard time. oh, I like this one. I'm ready for tough love from data. Right? Like, if you're approaching any type of data project with a preconceived notion of the exact thing you want from it, it's not good. Like, you need to be open to learning something that contradicts your intuition or that contradicts the things you want to find out. And that's, you know, it's even more, like, for predictive projects, that's a little less common. For analytical projects, that's super important. And I think a lot of organizations have, you know, that one person who approaches analysis projects from the perspective of like, oh, I just need to prove what I already know. It's just like really bad and evil, and I shouldn't do that, and bad. You're right, like a sense of realism, right? Like know what problems can solve with data and which are most important. Like have an understanding of how that data product we're trying to build would fit into your organization and what, not only what resources it requires, but also which impact it could have. Okay, individual buy-in, like between how data competent is your staff, between counting on 5 fingers and living in the matrix, right? Somewhere, you're like most people, somewhere between those two extremes. One really bad but possible heuristic is like, how many people in your organization have a job title that includes the word data? Like that's not the most detailed statistic to have about how competent your staff is, but if you have nobody in your organization with job titles like data or something like that. On the other end of the spectrum, you might have an organization where it's absolutely required every level of the organization to take in some kind of data each week, like to have some kind of learning from data each week on a very standard basis. That might be a huge part of the organization culture, and that would be great. All right, so for the lab project, that would be scored on advanced, because CDPH has a bunch of data analysis, statisticians, and so on, but they did not have predictive analysts, and that was a skill that was necessary to do the predictions of which house is likely to produce poisoned babies, but they were lacking this specific skill. But other than that, they had a bunch of very competent staff. Last one I'm showing you. There's more on a sheet of paper. Stakeholder mind, which is basically like the people on the ground who are like on a daily basis, they're collecting your data, right? They're helping you, like they're collecting the data, but they're also being the people who will act on your output, on the output of this project. Do they support you? Like, will they let you know something was wrong? Will they carry on helping you if the project runs over time? Like, this is important and difficult. Like, do you have buy-in from people who are affected, by the project you're trying to build? And the bigger picture question is really like, is your technology appropriate, right? Or are you building over the head of people? Like, are you not meeting your organization with? Cool. Now we will change pace. 30 minutes in. So we have 30 minutes left. That's the last one, so I know everybody's like, but that's fine. Can I have all people who would identify more as a project / I work in a social good organization than I'm a technologist, raise their hands. If you're more of a project than a tech person. And can I have everybody else, keep your hands up please, sorry, you can change. Can I have everybody else find one of these people and literally like join with them, sit next to them. And we're probably gonna have like 2 per project, like 2 technologists per project. Let's do that now. And in 30 seconds I gotta continue. So 30 seconds to find the project. What we'll do, each team, please pick, each team needs one of each sheet, okay? For each team, get the data sources worksheet, the questionnaire, and the 2 scorecards, okay? Then go through the questionnaire, your project person is leading that. Most questions will be directed at them. All the technologists help them ask the right questions, and if they are not sure how to answer, what they would need to do to find one of these questions out, like give them some ideas from your perspective. It's totally fine if not all these questions can be answered. Like a bunch of them would require like actually going back to where you work. So don't worry about that. Yep, that's it.